Hey everybody, it's Mr. Carr again. Today we're going to be talking about 5C day 1. This is our last method for solving systems of equations. Okay, this method is called elimination. And you're going to see why it's called elimination when we get into how it works. So it's not a clever name. It is what's going to happen. We're going to eliminate one of the variables. So here's the goal. You want to write your system so that like terms have the same number and opposite signs, okay, are aligned. And then you can add the equations together, eliminating one of the variables. So eliminating one variable. Then solve the equation. Substitute the value from step 2 into one of the original equations. Okay, original equations. And solve for the other variable. Then write your solution as an ordered pair. So very similar things with our substitution methods. Some people prefer this one versus substitution. Some people prefer substitution. It does not really matter. Okay. In the end, your goal is still the same. Find the point that the two lines cross. Okay. So here we're going to look at how elimination works. So solve using elimination here. First thing I'm going to check for is, are one of the variables lined up easily so that it's one negative and one positive? And do they have the same number? So you look at example 1, we get that here. We have a negative 3x and a positive 3x. So that works out. I'm going to just draw a line here. Like if I'm just doing like, for example, like 4 or 2 plus 3 equals 5. Okay. So that's how I'm going to treat this. Like everything's going to be vertical. Then down here is the sum at the end. So in this case, I've got negative 3x plus 3x is going to actually cancel each other out. It's eliminated, hence the name. For the y's, we have a positive 4y and a negative 6y, so that gives me a negative 2y. That's still going to equal, so the equal sign is going to carry through, and then you're going to have 12 plus 18, so that gives me 30. Well, now that's a very easy one to solve. I'm just going to divide everything by 2. So I get y equals a negative 15. All right. Now pick one of your equations and plug negative 15 back in. I like multiplying by smaller numbers, so I'm going to go with the first equation. So negative 3x plus 4 times negative 15 equals 12. And you notice now I've, like in the first case, I eliminated x, so now I have just one equation with y, just like with our substitution. The goal was to get one equation with one variable when I started with 2 equations with 2 variables. All right. So negative 3x, that'll be minus 60 equals 12. Okay, add that over. So that negative 3x is equal to 72. Divide by negative 3. And I get, I don't feel like doing that in my head right now. So we got what? Negative 24. That should be right. Yeah, negative 24. Okay. And just like before, our final answer is going to go as an ordered pair. Negative 24, negative 15. All right. Example 2. Now, this one's a little bit different because I did not start with a negative and a positive of the same value. Okay. But it's really easy to make one of them that. So I'm just going to rewrite this so I can have a little bit more space to work with. So we got 4x plus 2y equal to 28. 4x minus 3y equal to 18. It doesn't matter which one's which. Okay. So what I'm going to kind of do is I'm going to take this second one and make them all the opposite signs. So right here, what I'm really doing is I'm multiplying by a negative 1. So everything is multiplied by a negative 1, and I'm going to rewrite that then. I'll just rewrite them over here. 4x plus 2y equal to 28. Negative 1 times 4x is going to give me a negative 4x. Negative 1 times a negative 3 is going to give me a positive 3y. And then negative 1 times 18 is a negative 18. Now my goal is complete there. I wanted one variable to have the same number but opposite signs. So let's combine. 4x minus 4x cancels out. I'm left with 2y and 3y to make 5y. 28 minus 18 is going to give me 10. So now I can divide both sides by 5, and I get 2. Okay, so from there, again, plug it back into one of the original ones. And I'll pick the first equation because I got 2 times 2 from that. So 4x plus 2 times 2 is equal to 28. So 4x plus 4 equal 28. 4x, I'm going to subtract 4 over. So 4x equals 24, divide by 4, and I get x equal to 6. So my answer is 6, 2. So that is a very basic version of elimination that helps us work. We'll look at one word problem together real fast. Same thing as before. We want to model what's going on with this. Hardware store earned $965.50 from renting ladders and power tools last week. The store charged 36 days for ladders and 85 days for power tools. This week, the store charged 36 days for ladders and 70 days for power tools and earned $829. How much does the store charge per day for ladders and power tools? So again, just like I said before, kind of step one, I want to find my variables. I want to pick something that really answers the question. How much does the store charge per day for ladders and power tools? So we got 2 things going on. So we'll make power tools T for tools, and I'll do L for ladders. I'll do a fancy L to make it clear. So L is the price for ladders. T is the price for power tools. Step 2, let's model the scenario. Okay, in the first case, total was $965.50. That is from charging for 36 days of ladders and 85 days for power tools. So what we can do is we know that if L is the price for the ladders, if we take 36 times the number of or the price for that ladder, that's going to be how much money was charged just for the ladders, how much money was earned through renting them. And we're going to add 85 times T, and that comes out to a total of $965.50. Okay, for the second equation, similar idea, we got 36 days on ladders, 70 days for power tools, and now the total is $829. Now I'll just line that up so it looks the same. All right, so from there, here's what I'm going to do. As a little bit of a shortcut, instead of having to show the distribution of -1, I'm just going to I'm just going to put a negative sign in front of all the things right here in my second equation. And you see why? Because 36L and -36L will now cancel each other out. So 85 minus 70 is going to give me 15T. Okay, 965.50, and I'm going to subtract 829 there. 965.50 minus 829 is going to give me 136.50. And then I take that number divided by 15. So T is equal to 9.2 or 9.10. Okay, in this case, I don't need a round. This is what we're looking for. Okay, the price for power tool rental is $9.10. Okay, so then I need to find the price for the ladders. So I'm going to plug that back into one of them. I'll do the second equation this time. So we'll go 36L plus 70 times $9.10 equal to $829. All right, so $9.10 times 70 gives me $637. Oops. So 36L plus 637 is equal to 829. We'll subtract this over to both sides. So that 36L is equal to, sorry, give me 1 second here. 192. And then we could divide that by 36. And I get, okay, $5.33. Okay, it's actually 33 repeated, but because this is money context, we're going to say $5.33. So the daily charge for each of these For a ladder, it's $5.33, and for power tools, $9.10. Yeah, pretty good deal, in my opinion. Okay, so that's it for elimination. Again, the goal for elimination, the same number, but opposite signs. So what happens is you're able to cancel out one of your variables, and then you can just work through the problem. And it's, or like once you cancel out one of the variables, then you're just combining them into one variable and you can solve that easily. All right, that's it for today. We'll continue some more examples of elimination in our next lesson. But other than that, take care.